At the end of the topic, you will be able to add and subtract matrices, recognize the properties of addition, multiply a matrix with a non-zero scalar, check if the matrices are conformable for multiplication, multiply matrices, explain the properties of multiplication. Arithmetic operations. You will be very familiar with basic arithmetic operations like addition, subtraction, multiplication, and division. The same way, matrices can also be added, subtracted, and multiplied. Before going in detail about the operations on matrices, we will discuss the equality of two matrices. Consider a 2 by 2 matrix. A equal to 2, 4, 6, 8 and B equal to 2, 4, 6, 8. Compare matrix A and matrix B. You can see the corresponding elements of the two matrices are equal. Thus, matrix A equals matrix B. Hence, you can define the equality of two matrices as two matrices A and B are said to be equal if both the matrices A and B are of the same order or size and the corresponding entries in both the matrices A and B are equal. Now we discuss the operations on matrices. Addition of matrices, subtraction of matrices, multiplication of matrices.
Here are the properties of addition of matrices. Matrix addition is commutative. That is, if A and B are two matrices of the same order, then A plus B is equal to B plus A. Matrix addition is associative. That is, if A, B and C are three matrices of same order, then A plus B plus C is equal to A plus B plus C. Identity of property of matrix addition. That is, if A be a matrix of any order, then A plus 0 is equal to A is equal to 0 plus A, where 0 is the null matrix of the same order. Inverse property of matrix addition. That is, if A be a matrix of any order, then A plus minus A is equal to 0 is equal to minus A plus A, where 0 is the null matrix of the same order.
Next, let us discuss the property of subtraction. Difference of two matrices is a matrix formed by finding the difference of the corresponding elements of the given matrices. Consider the matrices A and B of same order. Order 2 by 3. Here we get the first element in the resultant matrix, matrix AB, as difference of 4 and 3, which equals 1. The second element in the first row is 3 minus 8, which is minus 5. The first element in the second row is 6 minus 11, which is minus 5. And the second element in the second row is 8 minus 7, which is 1. The first element in the third row is the difference of 9 and 6, which is 3. The second element in the third row is 15 minus 8, which equals 7. We observe that the order of the resultant matrix is of the same order as both the matrices. That is, here we have the order of the resultant matrix as 3 by 2. Next, let us discuss the property of multiplication of matrices. Consider the matrices A and B, where the order of the matrix A is 2 by 2 and the order of the matrix B is 2 by 3. First element in the first row of the matrix AB can be found as: consider the first row of matrix A and first column of matrix B. Multiply the first element in the first row of matrix A, that is 6, with the first element in the first column of matrix B, that is 2. Add this product and the product of the second element in the first row of matrix A, that is 9, and the second element in the first column of matrix B, 7. We get 6 into 2 plus 9 into 7. Here we get the first row in the resultant matrix AB as a product of 6 into 2 plus 9 into 7. 6 into 6 plus 9 into 9 and 6 into 0 plus 9 into 8. Similarly, for all the elements of the matrix AB, we have to repeat the same process. The element of second row is obtained as follows: 2 into 2 plus 3 into 7, 2 into 6 plus 3 into 9, 2 into 0 plus 3 into 8. Thus the product of A cross B is obtained as shown here. Thus the product matrix AB is defined only if the number of columns in matrix A is equal to the number of rows in the matrix B. The order of the matrix AB is M by N, where M and N are the number of rows of matrix A and the number of columns of matrix B respectively. Multiplying the elements of the ith row of matrix A with the corresponding elements of the jth column of matrix B and then adding the products, we obtain I, J, the element of the matrix AB. Now let's discuss the multiplication of a matrix with a scalar. Consider the matrix A of order 2 by 3 and the scalar 7. The product of the scalar K and the matrix A is the matrix Ka, which is equal to the matrix in which all the elements of matrix A is multiplied by 7. So, we get in the first row of matrix Ka, first element is 7 multiplied by 4 equals 28. Second element is 7 multiplied by 7, which is equal to 49. Third element is 7 multiplied by 3, which is equal to 21. In the second row, first element is 7 multiplied by 2 equals 14. Second element is 7 multiplied by 6 equals 42. Third element is 7 multiplied by 8 equals 56. In general, we can say if A is a matrix of order M by N and K be a scalar, then the matrix Ka is defined to be a matrix of order M by N whose elements are obtained by multiplying the corresponding elements of A by K.
Here are the properties of product of matrices. Matrix multiplication is not commutative. That is, AB is not equal to BA. Matrix multiplication is associative. That is, A into BC is equal to AB into C. Matrix multiplication is distributive over addition. That is, A into B plus C equal to AB plus AC. A plus B into C is equal to AC plus BC. Identity property of matrix multiplication is AI equal to IA equal to A, where I is a unit matrix. In this topic you have learnt only the matrices of same order can be added or subtracted. When a matrix is multiplied by a scalar k, every element of the matrix gets multiplied by k. Addition of matrices is commutative and associative. If A plus B equal to 0, B is the additive inverse of A. A null matrix is the additive identity. Minus A is the additive inverse of A. If M by N matrix is multiplied with N by P matrix, the product matrix is a M by P matrix. Product of matrices is not commutative. Multiplication of matrices is associative. Multiplication of matrices is distributive over addition.